Okay, so let's just talk about the p-value and I think it's the critical value in the next one that you missed here. They are the same process that we've had before. All right, so let's notice this is a right-tailed test. So that means when we look up this test statistic in Excel, we are going to subtract what we get from 1 because it's right-tailed. All right, so we also have a small sample size, so we're going to use the t-distribution. So since our sample size is 16, degrees of freedom are 15. All right, so with these, we want one less for the degrees of freedom. So our degrees of freedom are 15, and we're going to put this test statistic in 0.589. So if I go to Excel and I put equal t.dist and 0.589, and 15 we said was the degrees of freedom, and true, it gives me 0.717687. Now let's remember that I said since it's right-tailed, we have to subtract that from 1. So that's equal 1 minus 0.717687, which will be 0.2823 if we round to 4 decimal places. And let's notice, if we check, 0.2823 is the answer that it is looking for. All right, now, let's look at your second one here where you had to find the critical value. Now, again, it's a right-tailed test. So, but this is a critical value and not a p-value. So for our critical value, let's remember for a right-tailed test, let me see if I can. So for a critical value, let me put the draw feature on here. There it goes. I'm going to draw a normal curve. Probably not going to look too great since I'm drawing with my finger, but okay. Now, since it's right-tailed, that means we want this region over in the right to be 0.005, the value of alpha. But let's remember when we look things up, we're looking things up according to what's on the left. So if we subtract 0.005 from 1, what's on the left is 0.995. So we want to look up 0.995. And going back for a second, let's notice there were 17 test subjects, so small again. So we want to use t with 16 degrees of freedom. So Excel equal, this time t inverse, since we're putting a probability in, 0.005 with degrees of freedom 16, and we get negative 2.9207. Oh, I'm sorry. I goofed. I accidentally put in the right value instead of the left value. Let's do that again. Equal t.inv, we needed to put 0.995 and 16 degrees of freedom. And it's the positive 2.921. And we see that that's exactly the value that they have right here. So this is the same process we've used before. Just pay attention to what you're doing for critical values. You're using the t inverse function in Excel. And when you're using the p-values, you're using the t.dist function in Excel. So hopefully that will help you here.